For homework tonight, please complete page 12 and correct it with this section. Use the box plot below and tell whether each statement is true or false. Explain your reasoning. The class median is less than 80. Looking at the location of the median on the box and whisker plot, I can see that it is less than 80. This is true. Have the class scored between 60 and 80. Looking at the number of scores between 60 and 80, I can see this is worth 2 quartiles. This quartile is worth 25%, the other quartile is worth 25%. So that's a total of 50% of the students, or half the class, that scored between 60 and 80. This is true. At least one student earned a score of 100. I can see a maximum value of 100, so I knew at least one student was there. True. The class mean is probably less than the median. If I'm thinking about where I would have this balance out, I'm noticing that I have kind of a distribution that goes further to the left here, and so that might cause this to balance a little bit below where the median is. So I'm going to say this is true. Finally, if there are 30 students in the class, at least 10 scored above 80. 10 out of 30 students would be equal to 1/3 of the students. If I look at what the scores that are above 80 here, I will see one of the quartiles. And so that's about 25% of the students, which is equal to 1/4. So unfortunately, 1/3 is greater than 1/4. And so this is going to be false. Next, you're going to design a simulation that will help you answer this question. If you select 5 students at random from a class of 25, what is the probability that at least 2 will have the same birth month? We're going to design a simulation to model this situation. And you're going to tell which month each simulation outcome represents. One option you might have come up with is to use a random number generator and to go all the way up to 12 and to assign each number to a month of the year. So again, you could have said 1 is January, 2 is February, 3 is March, etc. Now you're going to use your birth month simulation to generate at least 25 samples of 5 people each. And I'm sorry, I should have said that this was sample 1 instead of student 1, because that would have made a little bit more sense. But you're going to generate 5 random numbers. So let's say, for example, I generate 5 random numbers, 5, 8, 7, 6, 6. So that means I picked 5 students. One was born in May, August, July, June, and June. And they doubled up here. And so what I'm noticing is that in this case, I would have had people who had the same birth month. Then you're going to continue out on all of your samples. Again, you want at least 25 samples, 5 numbers each. And so again, here's another example, 1, 11, 12, 10, 8. This time I didn't have any that doubled up. And so in that particular situation, right, I didn't have anyone with the same birth month. So continue all the way through if you haven't had a chance already, and then you're going to estimate the probability that at least 2 people in a group of 5 will have the same birth month. Again, this is where your answers may vary depending on what you found. However, what you may have been likely to find, having done this experiment multiple times, is that it should be approximately 60% of the time. So you can see how your values compare to that benchmark, and we'll discuss this more in tomorrow's class.